When you do a double replacement, you have to check the solubility rules. A reaction, a double replacement, will only work if you form a solid, form a liquid, and the liquid would have to be water, or if you form a gas. Your solubility rules tells you if you form one of those. So sodium chloride. Sodium is Na plus 1. Chlorine is Cl minus 1. So we have NaCl. And is my plus. Lead, Pb plus 2. Nitrate, NO3 minus 1. Pb, NO3, 2. So it's a double replacement reaction because I have two compounds. So I'm following along with number 4 on my reference table. There's only one way to write out a double replacement. AB plus CD goes to AD plus CB. So A in the problem is sodium, plus 1. D in the problem is nitrate, NO3, minus 1. So I would have NaNO3 plus C was the lead with a plus 2 charge, and B was chlorine with a minus 1 charge. So that's PbCl2. So then we're going to check our solubility rules to make sure that this works. The word soluble means that it's aqueous. It will dissolve in water. So soluble, we would put AQ. Insoluble, it doesn't dissolve in water, so it would remain a solid. The solubility rules are always based on your letter B and your letter D. Well, letter B in the problem was chlorine. So I find my rules on chlorides. And it says all chlorides except silver, lead, and mercury, and it's listed under the soluble. So chlorine is going to be soluble as long as it's not with silver, lead, or mercury. So this is going to be soluble, so I write AQ. The chlorine on this side, however, is with lead, which is an exception. So it's no longer soluble, but insoluble, and I write S for solid. The D part of the problem was nitrate. All nitrates are soluble, and the word except is not there in that rule. So all nitrates are going to be aqueous, regardless of who they're with. Because I formed a solid, I know the reaction has taken place. So now I can balance. I like to start with the polyatomics first. 2 NO3s, 1 NO3. So I'm going to multiply by 2. That gives me 2 sodiums. So over here I multiply by 2. That gives me 2 chlorines and 2 chlorines. So we're balanced. Copper 2 sulfate. Copper 2 Cu plus 2. Sulfate is SO4 minus 2. Anytime you have the two charges together, that reduces to Cu SO4. And is a plus sign. Sodium Na plus. Hydroxide OH minus. So that's NaOH. Again, I know that this is a double replacement because I have two compounds, so I'm following along with number 4 on my reference table. AB plus CD goes to AD plus CB. A in the problem is copper, Cu plus 2. D in the problem was hydroxide, OH minus 1. So I cross my charges and get CuOH2. C in the problem was sodium, plus 1, and B was sulfate, SO4 minus 2. So I cross my charges, Na2SO4. We check our solubility rules to make sure that this reaction takes place. We're looking at our B and D. B in the problem was sulfate. The rule with sulfate says all sulfates except calcium, strontium, barium, mercury, lead 2, and silver. We are with copper to begin with, so it's going to remain soluble so we write aqueous. At the end, we're with sodium, so it's going to remain soluble, and we write aqueous. Hydroxide was the letter D. So we look for our rules on hydroxides. It's listed under insoluble. So all hydroxides are insoluble except with group 1, strontium, barium, and ammonium. Well, sodium is in group 1. So this is no longer insoluble but soluble, and rewrite aqueous. On this side, the hydroxide is with copper. Copper is not a part of an exception, so this is going to remain insoluble, and we write solid, will not dissolve. So this reaction takes place because we formed a solid. To balance, I like to start with a polyatomic. 2 OHs, so I'll put a 2 here. That gives me 2 sodiums to balance these 2 sodiums, and the reaction is balanced. Aluminum chloride. Aluminum is Al plus 3. Chloride is Cl minus 1. So that gives me AlCl3. And is my plus. Sodium, Na plus 1. Phosphate, PO4 minus 3. I cross my charges, Na3, PO4. It's a double replacement reaction because I have 2 compounds, 2 ionic compounds. AB plus CD goes to AD plus CB. So A in the problem is aluminum. Aluminum is Al plus 3. Phosphate is PO4 minus 3. So we have Al PO4 plus C was Na plus 1. B was Cl minus 1. So that is NaCl. I look at my B and my D. B is chlorine. I look at my rules for chlorides. All chlorides are soluble except silver, lead, and mercury. So the chlorine with aluminum is going to remain aqueous or soluble. The chlorine with sodium is also going to be aqueous. PO4 is phosphate. So I look for my rules on phosphates. All phosphates are insoluble except with group 1 and ammonia. So here it's with sodium, which is in group 1, so it's no longer insoluble but soluble. Phosphate here is with aluminum. Aluminum is not a part of our exception, so it's going to remain a solid. So this reaction takes place because I formed a solid. To balance it, we can start with our chlorine. We have 3 chlorines, so we're going to multiply by 3. That gives us 3 sodiums and 3 sodiums, so it's balanced. Number 4, silver nitrate. Silver always has a charge of plus 1, and nitrate has a charge of minus 1. So that is AgNO3. And would be my plus. Potassium, K plus 1. Chlorine, Cl minus 1. So that would be KCl. It's a double replacement reaction because it's 2 ionic compounds. So AB plus CD yields AD plus CB. We're just switching our partners. A in the problem was silver with a plus 1 charge. D in the problem was chlorine with a minus 1 charge. So that would be AgCl. Plus C was potassium, K plus 1, and B was nitrate, NO3, minus 1. I'd cross my charges and I get KNO3. I look at my solubility rules. Nitrates are always aqueous regardless of who they're with, so both of these would be aqueous. Chlorine is aqueous unless it's with silver, lead, or mercury. So with potassium, it will remain aqueous, but with silver, it's now a solid. So this reaction did take place because we formed a solid. It also happens to be balanced. Number 5, hydrochloric acid. It's an acid, so it starts with hydrogen. It says hydro, so it's binary, and the other element is just chlorine, so it's HCl. And is plus. Lithium is Li plus 1, and hydroxide is OH minus 1, so that is LiOH. It's a double replacement reaction because I'm given two compounds, an acid and a base. So we follow along. AB plus CD goes to AD plus CB. Well, A in the problem was hydrogen, so that's H plus 1, and D was hydroxide, OH minus 1, so that's HOH, plus CB. C was lithium, Li plus 1, and B was chlorine, Cl minus 1, so that is LiCl. So we look at our chlorines. All chlorines are soluble except with silver, lead, or mercury. So H would remain aqueous. Lithium would remain aqueous. Hydroxides are insoluble except with group 1 and ammonia. Strontium, barium, and ammonia. So lithium being in group 1 will make this hydroxide aqueous. HOH. HOH, if you combine like terms, is actually H2O, or water, and water is a liquid. So this reaction takes place because we formed a liquid. It also happens to be balanced.